Okay, this is the second video segment. This time we're going to talk about timing and direction. We'll sort of revisit the basics there. We revisited the basics of plane and poi-length last time. This time we're going to do timing and direction. So the first thing I want to get out of the way right away is the concept of direction, and I want to kind of point out the fact that for the most part direction is sort of irrelevant. So long as you make the distinction between same direction and opposite direction, the rest of it really doesn't matter very much. All it is it's a way of allowing a spinner to differentiate between the moves that are difficult for them and the moves that are easy for them. This type of meltdown, for example, is relatively easy for me, but if I switch direction, I don't particularly feel very comfortable in this direction. In my opinion, for the most part, if you ignore the spinner's skill level, direction is, for the most part, irrelevant, with the exception of opposite direction and same direction. So, having gotten that out of the way, let's just talk about the basics of direction within the four different possible combinations. So, you either have same direction, same direction, same time, same direction, split time, opposite direction, same time, and opposite direction, split time. And I can define the poi that way, and I can define my arms that way. So same thing, I can have same direction, split time, same direction, same time, opposite direction, split time, and opposite direction, same time. So direction is fairly easy to define for this case. But I want to talk more, I want to look more closely at timing. Timing can be defined by the 9-square grid in sort of an interesting way. If you look at the what I've been sort of referring to as the points of convergence of the poi and how they relate to one another, you can come up with some very interesting relationships. We'll start with same direction. So just imagine, or view my spinning as it relates to this 9-square grid, and I'll spin in the center here, and we can sort of look around the outer perimeter of the square. If I'm in split time, my poi are defined as moving in the same direction in this case, and the heads are at 180 degrees opposition to one another. So for every square that one poi head is rotating through, the other one is rotating through the opposing square on the 9-square grid. If I go into same time, the heads have what I would refer to as an infinite convergence. They're together, sort of superimposed over one another. And as I rotate the poi in this way, you can see that they are following, or they're superimposing with one another through each of these 8 squares. If we go into opposite direction, for example, same time, opposite direction, the points of convergence of the poi heads at the top and the bottom of their spin tell me that this is the same time butterfly. If I go into split time, you can see the points of convergence are on the left and the right side. So that tells me that this is a split time butterfly. And so just by breaking down my space into a grid like this, I can sort of start defining the timing by how the poi heads are in relation to one another. This also applies to my hands, again. So I can be going same direction split time. My hands are in 180 degree opposition to one another the whole time, so they are on opposing squares as they go around. And if I go into same time same direction. My hands are superimposed over one another and they're following through the same square at the same time. And if I go into butterfly, this would be same time because my hands are converging at the bottom square and at the top square. And if I go into split time, my hands are converging on the left and the right squares. So, being able to define those points of convergence or divergence are going to be sort of pivotal to the rest of the 9-square theory. A lot of it is going to be revolving around that concept. Okay, the last thing I want to talk about for the last half of this video is going to be polyrhythms, because we've defined same time and split time. I want to go over another type of timing, which is called a polyrhythm. Polyrhythms are probably one of my favorite subjects. They're extremely important to the 9-square theory, which I'll go over in the next segment, how you can use them. But right now I just want to explain the structure of a polyrhythm. So a polyrhythm is when one poi is spinning, or your arms are spinning at different speeds. So for the sake of this demonstration, the black poi will remain at a constant speed, and I will change the speed of the red poi. So the two basic types of polyrhythms that people use, there are others, but mainly people use 2-to-1 and 3-to-1 polyrhythms. So a 2-to-1 polyrhythm is when one poi is going twice as fast as the other. So like 1, 2, 1, 2, 1, 2, 1, 2. And I can sort of define the qualities of this spin again by using the 9-square grid. If you look at the black poi and the red poi, when they meet together, you'll see that they are superimposing at the bottom of the arc, right there. So 1, 2, 1, 2. And you could sort of say that they're in same time when they're down here. The fact that they're superimposed is the important thing. If I look at the black poi at the top of its arc, you'll notice that if instantaneously speaking at that point, the red poi is at the bottom of its arc. So in a 2-to-1 polyrhythm, you can sort of define it by saying that for one beat, the poi are divergent from one another, and in one beat, the poi are convergent with one another. And again, this is going to be extremely important later on. The last thing I want to talk about is a 3-to-1 polyrhythm. So that would be sort of 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, 1, 2, 3, like that. A 3-to-1 polyrhythm can be defined the same way, except the points of convergence are at the bottom, at the top, and at the top, and the points of divergence are on the left and the right. So the poi are together at the bottom. Let's see if I can kind of... so it's probably too fast for you to see, but they converge here, they're 180 degrees apart here, and then they converge at the top again, and then they diverge here again, and then they go back together. So more on that in the next video. Your arms can be doing the same thing, so I can go, for example, 1, 2, 1, 2, 1, or I can do it in the same direction, so 1, 2, 1, 2, 1, or I can do it in 3-to-1, but I won't because I'll kill myself. And remember back from the first video that an extension is 3 times as slow as a regular spin is. And we'll kind of go into these relationships in the next video. So I'll see you then.